In this problem, we have to prove that for some scalar lambda, the vector x and y, which is given by this two format, satisfies the equation px plus qy equals to a and x cross y equals to b, with the lambda value given by a dot x divided by a squared. So let us begin. So we will first note down all that is provided to us. So we consider the equation px vector plus q times y vector equals to a vector. Let's label this as equation number 1. Then we have x vector crossed y vector. So this is equals to the vector b. Let this be equation number 2. And we have the lambda vector, lambda value, scalar lambda. So that is a dotted with x divided by a squared. And let this be equation number 3. So let's start with number 1, equation number 1. What we'll do, we will multiply both sides. We'll take the cross product with x. So let's say x crossed with bx plus qy. We have to do both sides. So we have x vector cross a vector. Right. So let's expand this. So this will be x cross px vector plus x cross qy vector, and this will be equal to x vector crossed with a vector. So p times we have x cross x plus q times x cross y, which is equals to vector x cross a. Now x cross x, this is going to be 0 because they are parallel vectors. So we're left with q times x cross y. But according to equation number 2, x cross y, so that's simply vector b. So we have qb vector equals to vectors x cross a. Right. So what we will do next is we'll take again the cross product with a on both sides. So that means we'll take vector a and cross it with qb vector. This will be equals to vector a cross it with x cross a. Now this is going to give us, so we have q is a scalar, so we have q times a vector cross b vector. So now here we'll have to use the vector triple product. But before that, I would like to state how did we know that we need to take the cross product a? Because here, if we looked at the expression for x, or if it is the expression y, we need an a cross b. So what we're trying to find out, we are trying to find out the value of a cross b from here. Right. So let's now expand. So all we have to do is, like, let's say we have the scalar triple product between a cross b cross c. So when we expand this, so this will become the vector b times a dot c minus the vector c times a dot b. And there's a very simple way to remember this. So this is simply the back cap mnemonic that we can use to easily remember the expansion of a cross b cross c. So what we'll do, we will assume that this a is equivalent to a vector. So x vector is equivalent to b, and this a vector is equivalent to c vector. Now if we use the back cap, so this will become x vector times a, so a dot c, so that will be a dot a minus, we did back cap, so cap, so this c will be a vector times a dot b, so this will be a dot x. Fine, let's work with this now. So we have q times a cross b equals to x times, so a vector dotted with a vector, that's simply a squared, minus a vector multiplied to a vector dotted with x vector. So from here we can isolate x vector a squared. So we have x vector a squared, that will be equals to a vector times a dotted with x vector plus q times a cross b. So now we have vector x. So we're dividing both sides with a squared. So we have a vector multiplied to a vector dotted with x vector divided by a squared plus q times a cross b divided by a squared. So we have obtained an expression for vector x. However, we can have a vector dotted with x vector divided by a squared. So here we can use equation number 3 and replace it with lambda. So this is going to now give us x vector equals to lambda times a vector plus q times a vector crossed with b vector divided by a squared. So this is an expression for x that we have now obtained. So let's verify. So this is the expression for x vector that we have obtained just now. Next, what we'll need to do is obtain an expression for the vector y. For that, we have to again consider equation number 1, 2, and 3. So we'll use them. Let's do that. Now we consider equation number 1. Now earlier when we were trying to find out the value for the expression x vector, we took the cross product with x vector. So this time we'll consider equation number 1 and cross it with vector y. So this is going to give us, so we have px vector plus qy vector. We'll take the cross product with vector y. So this will be vector a crossed with vector y. So let's expand this. So we have p times x vector crossed with y vector plus q times y crossed with y. So this is equals to vector a crossed with vector y. Now x cross y, so this will be replaced with vector p. So we have pv vector. Y cross y, this will be 0 because they are parallel vectors. This will be equals to vector a cross y. Fine. Now what we will do, we need a cross b. So we will again take a cross pb vector, and then we have a crossed with a cross y. This is done because we know that when we have to find the expression for y vector, there is an a cross b term on the right hand side. So that's why we have taken the cross product with vector a. So this will be p times a vector cross b vector, and we use the back-cap method. So this will be, let's write it down, this will be easier. So we have back, so back will be vector a multiplied to a dot y minus cap. So cap will be cy vector a dotted with a. So let's bring this to the left hand side. So we have y times, so a dot a, so this will be simply a squared, and we'll take this to the right hand side. So we have a vector multiplied to a dot y minus p times a cross b. Now we'll divide both sides with y squared. So we have a squared, not y squared. Y will be equals to a vector multiplied to a dot y divided by a squared minus p times a cross b divided by a squared. So now task will be to determine the value of a vector dot y vector. So for that, we again go to equation number 1. So let's use it. So equation number 1, we have px vector plus qy vector equals to a vector. So what we need to find? We need to find a vector dotted with y vector. So we'll take a vector and dot it with both sides. So this will be outside. So this is px vector plus qy vector equals to a vector dotted with vector a. Let's expand this. We have p times a vector dotted with x vector plus q times a vector dotted with y vector. So if we isolate this, we can obtain the value of a vector dot y vector. And a vector dot a vector, so that's simply a squared. If we look at a dot x, this can be also replaced by using equation number 3. So this will become p times lambda a squared plus q times a vector dotted with y vector equals to a squared. So now we have q times a vector dotted with y vector, and this will be equals to a squared minus lambda a squared p. So we have a vector dotted with y vector, so this is equals to a squared times 1 minus lambda times p whole divided by q. Now again, we can divide both sides with a squared, so we have a vector dotted with y vector whole divided by a squared, and this will be equals to 1 minus lambda p whole divided by q. So now our y will be, so this is not y, this is actually a y vector. So this y vector now will be equals to vector a multiplied to simple multiplication. So we have 1 minus lambda p divided by q minus p times a vector cross b vector all divided by a squared. So let us compare with our given expression equals to 1 minus p times lambda divided by q times a vector minus b times a cross b divided by a squared. So this is what we have obtained.